Hello everyone, it's December the 16th, but we're doing for the 17th. It's a good day today. Finally, I think my semester is all done. I did my committee meeting today, had a pretty good response. The past 3-4 days are quite hectic. Now we went through a lot of papers and then tried to write up how my next plan was and summarize what the semester has gone. Semester went so fast. Man, I feel like it's just summer. And then, no, blink of an eye, we're already at the end. Very difficult class I've taken, convex optimization, but probably one of the best classes I've ever taken. Pushed me really beyond what I was, what I thought I was capable of. I mean, from time to time, these type of classes and these type of teachers are the real ones that can bring you to the next level. So next semester, no question about it. Well, I won't take his class, but I don't want to quote unquote waste credits, but I will attend his class. He's a really good teacher. Yeah, the pushing. I mean, we're talking about people need to be nice. You need to go slow on your learning. Just to don't chew too much, then you can bite off. But sometimes you do have to chew something bigger than you can bite off. I mean, not too much bigger, but they gotta be bigger than what you're capable of, because that's how you grow, right? That's how you grow. You go into the uncomfortable zone. You get out of a comfortable zone, right? You just always doing things by tutorial, but one day you need to dig into what does tutorial actually talk about, right? Go into the nitty gritty. Go into the math. Right? Go into the math. I mean, I agree. Like there must be some level of knowledge. Like, I mean, in optimizations and machine learning, the basic skill is called linear algebra, right? You need to have that. Well, linear algebra and probably also differential. Is that differential equation? No, partial differentiation. I mean, these are not really hard. I mean, we're not doing like mathematics department kind of thing. We're just using the tool, right? Using the tool. Linear algebra is a great tool, but you got to get used to it. Okay? Get used to how things go, right? How things can be simplified. But anyway, I just feel like this whole semester, the investment, time and effort, and all the crazy time and try to tear my hair out. I just couldn't find proof. All the frustration, I think, eventually paid off, because I was able to read the paper on optimization topics and really decipher what the math is about. I mean, I cannot do all the math. There are certain part of the math I was like, maybe not. Like certain part I cannot do, but most of it, at least the paper I've been reading, it's at my level or slightly above my level. But I think that's how you grow. Well, anyway, so let's get into what we have today. So first question is maximum square, which I kind of remember. It's an old question. So let's take a look. And then we did pretty well yesterday. We solved all the problems that we had yesterday. Oh, look at that. Look at that. This is a very recent problem. Very recent. I think last month. Yeah. All right. I need to. How do I reset the default? Well, I try not to read it. Reset the default. No, I'm trying my best not to read it. All right. There's a maximum square, and there's also a maximum rectangle. And honestly, I already forgot how to solve maximum rectangle. How do we solve maximum rectangle? Jeez, man, I forgot. I forgot already. Maximum rectangle. Maybe it'll come back to me. I think maximum rectangle. Oh, I remember maximum rectangle is we keep track on. Oh, hold on. Almost there. Maximum rectangle. It's the same as finding the. Yeah, maximum rectangle is the same as the question of finding the maximum rectangle on histogram, right? So we will read the entire thing and then going down, just record. So we treat these as histograms, right? And every time, oh, I got hair in my mouth. I was hugging my cat earlier. So every time we go down a level, then we have the height. And we basically will record the heights, right? And then we run. And then what do we run? We run a, what's that called? Monotonic stack, right? So we do a monotonic stack, which can help us find the maximum, right? So I think each time, wait, hold on. Do we go all the way down? I actually don't remember. Do we just keep going and like each one I run? Yeah, I think it is each one. At each row, we'll run a monotonic stack. So we'll grab the maximum, and then the next row, then we keep growing if it can grow, and then we run the max, and then so it'll be O(n) squared. I mean, actually, we can try it here as well. But that's not, because this is a square, that's not a rectangle. Really, O(n) squared for the other thing. That's a good question. I actually don't know. But it has to be. All right, we're going to go back to the maximum rectangle later, but let's solve this one first. I remember correctly, to solve this, we will do the maximum. So we want to find a maximum, so maximum square. To find a maximum square here, we need a maximum square here, maximum square here, and maximum square here. So the maximum at here will be the max of this, this, and this plus 1. That's what I remember. And if you think about it, it doesn't make sense because the maximum here, right, whatever it is, and the maximum here, so that determines the reach vertically and horizontally. So we pick them. Well, I was just saying maximum of it. Actually, no, it's picking the minimum of it. So we're picking the minimum of this. So we got a stretch, and we also needed this one to kind of get it diagonal wise. There's a stretch. So the minimum of the 3. So yeah, so we can do this one. See, that is the benefit of going through these things. And I'm pretty sure this one, wait, was this one part of the challenge? It's either part of the challenge or it's actually the thing that I was doing just on myself. I don't remember. I don't recall. It could be part of the challenge. Yeah, but if it's part of the challenge, it doesn't make any sense to recycle it like today. So it's only been not even a month. No, I don't think this is part of it. I think this is part of the problem. I just do, separately. It's all fine, It's all about the practice. It's all about the practice. And the difficult part is also about, when you see these questions over again, can you remember the previous solution? Sometimes it's just hard. You can't. All right. So since we've done it before, right? So we're gonna do it in the manner of, can we do like it's a DP, right? And we can do DP with a saving on the space, right? So we want to check this one. So we want to look this. That's the previous one, which is exactly what I'm right now. But this one updated, I need it. But what about this one? How do I get these two? So I can use 2 arrays, right? I can use 2 arrays. But I have seen in the others, we can do it from right to left. Can we do it from right to left? So I want it here, right? and I have this, that's good, and that's also the previous one, but I don't have this. This needs to be the new one, so I cannot go right to left, so I need to erase. We use to erase then, that's fine. That's fine. Never a problem using to erase. So of course we're gonna first get the M and N, make things easier. Right? Then what? Now when you DP, actually DP, the first one is the same. Right? The first layer is the same as this. I'm gonna go by layer by layer, right? Layer by layer. And then that's the first layer, and we need a second layer, and the second layer we're just gonna check. Yeah, if it's this, then it basically means it's 0. Okay. So we're gonna say dp equals matrix 0, first layer, and we're gonna go layer by layer. So for this in range, hold on. We need to go through each row anyway. So I can just go for row. For row in matrix 1, because I don't need to go through this one again. This one already tells me. And we want the maximum square, so we need a max, right? The max will equal 0, and max equal to 0, the rest equals to 0. All right, so we are at a row. Then we're gonna go one by one, but we need a temp. That's for the next row. And then we're gonna say for cell in row, right? For the cell, we also need I. Do we need I? We do need I. So enumerate. So we're gonna enumerate this row. Now what do? We're gonna check if cell is 0, then we're gonna append 0 to the temp. All right. So we say if not cell, temp.append 0. Otherwise, if it's 1, then I'm going to check this, which is dp. I'll check this and check this. Then we're going to say temp.append. It's going to be the minimum value, right? Minimum value of something, and then plus 1. So it's going to be 1 plus the minimum value. So what is this minimum value? So the minimum value is the one above me, which is dpi. That's the one right above me. And I need dp I minus 1 and the current row I minus 1. But there's a trick because I can be 0. So it has to be if I, right, if I is larger than 1. Now I is larger than 0. So I might as well we do it, code it more clearly. So we say else 0. I mean, we can just say multiply, right? We can say this one multiply I larger than 0. If I is equal to 0, then it's going to be 0. Right? And then it's the same thing times I larger than 0. So that's the win append. Once we finish append, actually once this is done, right, then we say res equal to, what do we need? We need a size. So res will equal to max res temp minus 1 squared. And at the end, we return res. All right, time to check. Oh, I just, it's a string. Come on. I want to make it weird. So we have this. The answer is 4. What's the other one? This answer is 1. And this answer is 0. Answer is 0. Okay, let's try matrix. I've done a lot of matrix these days. Maximum square matrix. Let's run it. My bad. No. Oh. Oh, shoot. Shoot. I can't. I have to be int for seeing this. How about this? Still not right. I already inted it. So these are int value, and then append 0. Oh, row. You have to int this one as well. Wait, why do you do row? It doesn't make any sense. Stupid. This is a temp. This is temp. All right, now we have index out of range. Why would out of range? This one is the same size as each row, right? And then we go through each row. If it's 0, we append 0. If it's not 0, we're gonna append something. Append 1 plus the minimum, I minus 1, and temp, I minus 1 times. There's no I minus 1 on a temp. So I cannot use this trick. Okay, that's fine. If else 0, right? Same thing. If I was trying to be cheeky, else 0. And in this case, I'd rather do it this way to make it even more readable. Right, so this is what we're talking about. Now we run. Okay, we have an issue. We have an issue. Why is that? That is interesting. Okay. What went wrong? So we have the first row, right? We have 1 0 1 0, and then the second row will be the second one. Oh, I forgot to update dp. dp needs to equal to temp. Yeah. Now we're right. Okay. I have confidence on this. I've done this before, so we shall be right. Oh, we got wrong. What the hell? I see. Only one row, right? What do I do? Can we just... What if I start from the beginning? Right? I just set this to this, and now we go. And if it's 0, we append 0. If it's 1, we're gonna append minimum dpi. Well, I think the problem is we don't have a dpi. Well, if I is 0, dpi, we start as 0, right? And then they don't have anything because I haven't appended anything. So to start with, this has to be if I is larger than 0. Wait, larger than 0? Because the thing is, when I start, dp is an empty array, right? So I have an I, dp don't have anything. So I do need something in dp. Not really. Not really. Let's see. I think what we need is an I here. All right. So we're gonna do enumerate matrix, and we put J here. All right. I'm gonna say if I is equal to 0, that's the first one. Then we just say temp.append int cell and continue. All right. So we avoid all the trouble. And then elsewise, we do this. That's not right. What the hell? Oh, these are not I. Alright, come on, man. These are J now. I changed it. These are all J now. Okay, now we guarantee that the first row, we set the first row in here. And which means the failed test case shall pass as well. So that's the failed test case we have. And this one shall pass as well. Aha! I said it's going to pass. Oh. Oh, I need to do rest. Shoot. Shoot. Alright, let's combine. So if this is fine, otherwise, temp gonna append. I can just do. Alright, let's not do this. Else temp.append 1 plus either minimum. I'm gonna say if minimum this, right? If I is larger than 0, else 0. Still not right. How? I probably need another parenthesis on this. Yep, I do need another parenthesis. Oh, now it looks as ugly as it can be. How do I rescue this? So we have all these, and we have another if and else. Oh my god, this just looks too ugly. This looks too ugly. Can we do it differently? If this is right, how about elif? How about elif? Elif. So cell is 1, and now I don't want elif. I want else. And we say if I is equal to 0, then temp.append 1. Right? Else. So now we don't need this. We don't need this anymore. So we can make this slightly easier. You know what? I don't care. I'm going to put them in one line. They just look too ugly. Right? So that's that. I can append this. And after this if and else, then I'm going to do the rest. So the rest will hit no matter what. And yeah, this seems to be better. A little bit slippage on the solution. This one shall be right. Yep, this one's right, but why is it so slow? I'll check out this one and see why it is so slow. So it's old question. I forgot which question it is. 221. All right, so LeetCode 221. I've solved this less than a month ago. So the solution is still I say vivid. It's still with me. It's still with me. However, it still took me 2 tries to pass the OJ. DP solution, right? And at each new cell, we check the cell to the left, above, and diagonally to the upper left to find the minimum side, right? To find the minimum side of square. Then the current cell's side of square is that minimum value plus 1. This will O(n) squared because there are 2, right? O(n) squared, and we run pretty fast, 336, and at 16% ranking. And that's probably because we have too many if and else. Yeah. Wanna try it if we remove one SNL, SF, and an else. Yeah, we can. We can do this, right? And then we can just go through the first row. We're gonna say for a cell in matrix 0, right? And then well, actually, let me redo this. dp equal to int c for c in matrix 0. I'm just trying to remove some f and else, and then rest will equal 1 if sum dp is larger than 0, else 0, right? And then if we do this, then we don't need to check this. We only need to check this. I run it. Yeah. I'll try this. See if this one gets any faster. Maybe it does. Maybe it doesn't. Who knows? I don't see why it would go faster. It should be similar. What? Hold on, how? What is the difference? You play with these solutions and you find out, man. You find out. This shall be 1. I got 4. That's not right. That's not right. And this is on the first. Oh shoot. Should be 1. Yep, my bad. Shall be 1. It's this one. Oh, and then we don't need to enumerate because we don't have I anymore. It's just gonna be matrix 1, right? We do need to enumerate on the one below, but on this one we don't need to enumerate. Okay, that one this one should be right. And I hope. See, it does clean up. And maybe one more thing. We didn't use this, right? MN, we don't even use MNN. So these are actually not necessary. Let's just make it shorter. Yeah. But I'm not going to keep running. This is the same thing. So update by remove. I mean, we can further remove. If you think about it, we can further remove. We can further remove. We can further remove by doing this. 0 plus, right? And then this is blah and blah. These are all fine. And we're going to start with a 0. And now we're just going to do this, right? dpj. And, well, for one thing, we have to go. That's when this comes in. I see now. I see now. So what do we do now? We need n equals len matrix 0. All right. So we add 1, and then we do this, and now we just say for j in range 1 to n plus 1. All right. Instead of cell, which only appears once, we can just say a row j minus 1. Right? If it is 0, blah, blah. Otherwise, we don't need to do this. We don't need to do this. Right? And then we not only saving rows or saving lines, we're saving quite a lot. All right, so update by reducing conditional checks. We can speed up the runtime. Let's try this one. This is my new solution. What I hope is, why don't we just do any dp, and we put this into an int, right? Let's see if this one gives us faster. I mean, these are just slightly faster. They don't really mean too much, but it's nice to see. We'll go back like down to 200. Yeah, that's to 200. So this one get to 212 milliseconds, which give us 59%. That's better than the first one we had. So now we also know that this solution is what we had last time. We're gonna just check. One array. No, it's also still 2 arrays. 2 arrays and a hold of pre. Why do we need pre? dpj minus 1 and dpj. So we just need to update the pre. Where do we update the pre then? dpj res equals this, pre equals temp. And the rest is the actual. We can save on here as well. Yep. That is the saving, so we don't have to do this every single time. Yeah, that is the saving. But anyway, that's fine. So it's the same thing. Yeah, only less than a month ago. Okay, we've done this. All right, let's move on. Move on. Lexical graphical numbers. Given an integer n, let me close this one. What do? Return all the numbers in the range 1 to n, sorted in lexical graphical order. Oh, the worst order in the world. I hate this with my guts. I have sensors named, and we name it wrongly without putting a 0 at the front. Oh my god. And then it's just so hard. Like, you sort it, but you still cannot find the one you want. And the worst thing is, our sensors are already out there, and the database is already set up. A lot of things are depending on a lot of things, and I'm scared. Right? I don't want to change it, even though I really want to change all these to 0, 1, and 0, 2, but I can't, because I might break something. So no, I hate it. I hate it with my guts. But still, we're gonna do this. So 13, we're gonna order it. The easiest way to do is using Python, which is, yeah, we can actually do it, but that doesn't count, right? That doesn't count. So basically, we say str, right? We're gonna do stri for I in range 1 to n plus 1. Oh, they require you to use on time. It doesn't matter. We just do this first, and then we say sorted, and then we need to return back as int. So we need to return this one, and int. Let's say s for s in this, and return a list. Yeah, this shall pass. I wish submitted this, but again, this doesn't count. So we're just gonna do this for fun. See how fast it can get. That's what I would do. Like, if let's say we want to run this in an app, all right? That's how I would do it. It's not slow. It's not slow. It's fine. All right. So we've done the cheating way. Now let's try to do it the real way. It says on time and O1 extra space. Wait, how do you do O1 extra space? You need to return an array. That's already O1. I think the idea is, in addition to this, it's going to be O1 extra space, right? That's what it means, extra space. Okay, so ON, and the previous solution is not ON. We sorted it. That's ON login, right? But basically, it says when you're starting doing it, you probably need to put in the right spot. How do we know where the right spot is? Well, based on where you end, right? So this one ends at 13, which started at 1, right? So we know the last position for 1 is going to be, that's 0 to 3, that's 4, right? And then plus the 1, that's 5. So 1, 2, 3, 4, 5. So 2 need to happen here, right? So based on the value we have, let me get my paper. And remember, we get the number larger. All the values are preset in position. Like we get 50, right? So all the teen numbers, all the 20 something, 30 something, they're all already ordered. Oh, I think the difficult part is when we go to higher values. Interesting. So basically, what you're saying is we need to compute each value's index. Okay. So we create an array of size 13. That we can do. Right, we create an array of size 13, and then the value comes in, right? 1 comes in. What do we do? So if it's 1, shouldn't 1 be like specially treated? 1 is always going to be the first position. 2 comes in, right? Now we have 2. So when 2 comes in, we need to figure out where it should be, or anything, 20 something, 30 something. So we have the starting position, and then we have the second position, and all the way to the end. So for each position, we need to compute. That seems to be harsh. I don't like it. I don't like it. And if you think about it, if we have, let's say, 100 that can be inserted in between. Wait, where does 100 go? That's actually a good question. Where does 100 go? Lexical, graphically. So 100, is it smaller than 11? No, it is smaller than 11. Oh, I'm gonna lose the internet. Come on, internet, get back. Okay, I'm back. How do we find the largest 2 digits? Well, we take a look at n, right? We take a look at the n, and then we say, what is n? If n is larger than 19, then all the 2 digits start with 1 is there. If not, right? If not, then we find the biggest. Let's see if it's within 2 digits. Within 10 to 19, right? The largest value, if it's within 10 to 19, then that's the end position. Otherwise, okay, so that's easy to tell. So we can find all of them, right? But then the next question is, between 10 and 11, now we have the same problem, right? From 10 and 11, there will be a 3 digits value. I feel like recursion to me. How can we do it efficiently? So we do 1, right? Next one we search for shall be 10, right? We see if 10 is in there. If 10 is in there, the next one we search for 100, see if it's in there. If it's in there, next one we search for 1000, if it's in there. If that one is not in there, so we don't go, then we search for, so now if this one is not in there, so we go back to 100. So now we want to see the next value of 100 is what? 101, right? 101. So we have, because we don't have 1000, so there will be no more in between. So now we need to find basically 100 to 109. See how big we can extend. And then we say, okay, all 109 is in there, so we just insert 101 all the way to 109. Once we're done with the 109, this stretch is done. So now the next value we want to find is, 109 done. So next one is 11, right? 109 is done. So next one is going to be 11. How do we know that? So it will be 109, or whatever the value it is, and also we exhaust. So this one is ending. Then we just go 1 back, right? We go 1 digit back, and then increment it, and then we go 11, and then we check if 11 is in it. If 11 is in the range, that's good. Then we now can look for the next one. The next one will be part bigger than 11, so it can be 110. So we try to find 110. Is 110 in there? If it's not in there, right? Let's say 110 is not in there, so none of the 110, 111 can go. So that's no good. So we need to find the next one and bigger than 11. So what we do is 1, 1. We take away the 1, add a 1, that should become 2. Well, then no, we have the plus 1 first. Not bad. So we plus 1 first. Okay? So we plus 1 to see if 12 is in it. Yes, of course. We plus 1 first to see if 12 is in it. If it is, then we add 12. Then we try to see. So once we add it, and the next step is always we try to add a 0 to it. Okay? So we add a 0 to see if it's in it, and then it's not in it. Then the current one we add. So always the first step is add a 0, right? We add a 0. If it's in it, we add it, and then we add a 0. If add a 0 is not in it, we add 1. Okay, and if it's add a 1 if add 1 is not in it, then we remove it, and then add a 1. Well, that seems to be viable. Okay, so let's say 12 is in it. The next one I check 1, 2, 0. If 1, 2, 0 is not in it, then basically we're gonna say, okay, we're back to 12. Then 12 we're gonna plus 1. It's gonna be 13. So we add 13, right? And then 13, we check 1, 3, 0, right? Check 1, 3, 0. Is 1, 3, 0 in it? If it's in, we append 1, 3, 0. And now we're gonna check 1, 3, 0. We're gonna check 1, 3, 0, 0. If that's in it, that's good. And then we always, if that's not in it, we check 1, 3, 1. If it's in it, good. And we go for the next one, will be 1, 3, 1, 0. It's not in it, 1, 3, 2. All the way to some 1, 3 some value. And it's not in it, right? If we add 1, it's not in it. So now we're gonna just discard it. And then so it's 13 plus 1. Okay, okay. This seems to be the way. This seems to be the way. Let's try 386. And that is ON, because every value I only use it once. I checked it once. Every value I checked it once. Okie dokie. Here we go. So, oh, in this case, we can just result is just gonna be this, and we just basically say for no, result is gonna be 1, because n the smallest value is 1, right? So it's rather than be 1, and then when do we end? Well, we end, the last value is 9, right? Last value was 9. And 9 we cannot plus 1. So the largest one is 9. Actually 9 something. So we do 9, and then we do 9, 0, whatever. So eventually we'll go back to 9, and we would like to 9 plus 1. So 10. So 10. 10 is the sign that we are ending. The current value is 10. Well, that's actually not true. The current value is 10. It has to be 9. And then we want to append a 10. Now, you know what? Let's just do len. While len res is smaller than n. Let's check the length is 01, so that's fine. Now what? Now we're gonna do is the value, right? Current value is res minus 1. So what we do is we're gonna say this times 10, right? So we're gonna say if res minus 1 times 10 is smaller equal to n, which means it's inside, then res dot append res minus 1 times 10. Then we go back. Else, right? So if a times 10 is larger, right? If the times 10 is a larger, then when you say elif res minus 1 plus 1 is smaller or equal to n, res dot append res minus 1 plus 1, right? And that is still not in n. Else, then we need to say what? Else, then we need to go this one, because I cannot add 1 anymore. So I need to divide it by 10, go to the previous, all right? So we go to the previous and then plus 1. So elif res minus 1 divided by 10 plus 1 is smaller or equal to n. And then res dot append this value. All right. Okay. Do we have an else if that plus 1 is still smaller or equal to n? What do we do? Oh, why would that be? No, that's not gonna happen. If we have divided by 10 and plus 1 is smaller than n, like larger than n, divided by, so we have something, right? We have some res value which is good, which is larger than n, which is smaller than n, and I divide by 10 plus 1, it's definitely going to be smaller than n. So we can always do this. Now we do this until we have filled all the values, and then we just return res. All right, I'm not 100% sure that this one's going to work. I'm going to run some examples. Oh, this actually we're going to run. I know we're going to run. Test is just going to be list range 1 to 100, all right? So that's no answer. We're just going to say for n, for in in tests, all right? So res equals solve lexical order and answer will equal to basically what I just did earlier. What did I do? I say sorted, no. And I say this int strs, all right, for s in sorted. No, this is not str. Come on, this is int. Int s sorted str I for I in range 1 to n. Right. So with this, for that's str, we sorted, and after sorted, we can do this and run it. We have invalid syntax. What? Oh, forgot I. It is not right. Okay. Huh? Oh. So for one thing, it should be n plus 1. Okay. Now we're right. 100. Nope. Yeah, we have issues. Let's say 20. 20 pass. So I think we can handle all the way to 99, right? No, we cannot handle 99. Huh. Interesting. They cannot handle 99. All right. I want to, of course we do this, but when we comment it out, I want some specific test cases. 30 is no good, but 20 is good. No, 20 is also no good. 10 is good. I think all the way to 19 is good. But 20 is not good. Let's see what goes wrong. I got 1, 10, 11 till 19. Where do your 2 go? Oh, I don't have 2. Ooh. Okay. I shall first check. Bummer. Bummer. I do need to check it first. But how do we solve this problem? So basically we have 19, right? And then 19 times 10 is too big. 19 plus 20 is good. That's why I put 20 down. But I shouldn't put 20 down. Okay, let me think. So every value we need to first times 10. That's understandable. The times 10. And if it's times 10 is too big, then the current one plus 1. But, yes, plus 1, if it goes above, then we need to be cautious, right? Which means if, how shall we do this? If this, the last digit, right? Basically, when you check if the last digit is not 9, how do we check the last digit? Okay, mod 10. Every value is mod 10. Is there an easier way? Mod 10. Okay, let's just say we mod 10, right? So mod 10, basically say mod 10 is not 0. So if this one mod 10 and the plus 1 is smaller, then we do this. Aleph it could be in mod 10 or it's too big. Oh, that sounds reasonable. So we just say if res minus 1 mod 10 and that is still not right. Now we have 10 appearing twice. So 1 and a 10, and I'll have mod 10. Yeah. That's not right. It's not this one. It's after. So we say if this one's smaller and res minus 1 plus 1 and this thing mod 10 is equal to 0. Right? It's like plus 1, it become okay, mod 10. If that happens, then we actually no, this is just like not equal to 0. Okay, so this one's good. Now we go back to this. Everything passed, so I don't want to print anything. I just see if it's not equal to, then I print. Okay, now we go to 1000. All right. Shall we cancel this? Yeah. Are you canceling? We canceled. Okay, so it's not working. So we see until, so like 200 works. 200 doesn't work, but 100 works. So we have the same issue with 2, right? So everything I think is fine. Oh, we don't have 2 again. Ah, so this one needs to, oh, shoot. Shoot. We need to divide it by 10 until, depending on how many zeros I have. Ah, okay. Makes sense. So, now what do we do? So we have a value, right? And then we say +1, smaller, and no, it comes here. So basically they say either +1 is too big or +1 is do this. Now we are going to else it, right? It's definitely going to be smaller. I don't even have to check. So basically, when let's just say while res -1, +1, right? When you say temp equals res -1 +1, right? Is too big, then we are just going to say while temp mod 10 is equal to 0, so it can be divided by 10, then we say temp equals 10, right? And if it's not equal, then, so it's, if it can divide 0, then I'll take away the 0, divide 0, I take away the 0. What if it does not divide by 0? Well, if this value does not divide by 0, then we think. Hold on. So if it +1 is smaller than n, or it's, which means if a +1 is larger than n, or +1 is divisible by 0, I will take away the 0. I'm going to go back, check again. That seems to be a better solution. So an if is this, right? And an else, while, now we have a temp. Temp equals res -1. While temp +1 is larger than 0, or temp +1 mod 0 is equal to 0, then temp divided equal to 10. So we go through all this. Once we're done, then we're gonna append temp +1. And then we don't need this. Run it. Pass. Okay. Do we dare? We dare. And it takes forever to run. Wait, hold on. This will take way too long. Are you serious? 17 seconds. But we're correct. So now we can go for it. Can we simplify any of these steps? I don't think so. I'm just gonna submit it. It'll take a few rounds. All right, the ultimate test that I don't want to do it on my laptop because that's just way too big is 50,000. All right, that's the maximum. So just run this, see how it goes. If this one works, then we're good to go. This is good to go. All right, this one will pass. I'm pretty confident this one will pass. And this is ON, right? Oh, we have a little bit checking here, but each value at most, because we do divide by 10, right? So we take away. So at most, this one will do 4 times. So the overall is O4N, which is ON. So yeah, that is ON solution. So yeah, we got this one, yeah. So yeah, I do the question a little bit earlier, where the brain is a little bit, and I don't think it's the time issue. I think it's just over the past week have been, really lots of stress with all the schoolwork and committee meetings and stuff that kind of affects the performance. And today, when everything's done, I feel very light, and that's probably why. Okay, so let's summarize it. So, in summary, we know a 1 must be at the beginning. Then, for each subsequent value, we check the end of the sorted result, right? We check the end of the sorted result. First, we check, how should I put it? So for each subsequent value, we check what should be the next value to append to the rest. To do that, we obtain the last value in rest. Now, the first check should be rest minus 1 multiplied by 10. If this is possible, we appended it and loop again. If it is not possible, then the next value could be rest minus 1 plus 1. Then we check the validity of rest minus 1 plus 1. Now there are 2 scenarios that will make rest minus 1 plus 1 invalid. 1, rest minus 1 plus 1 is too big. And 2, rest minus 1 plus 1 is divisible by 10. All right. Either these 2 scenarios are encountered, we need to remove the last digit of rest this and try again. Now the reason for this is that should we explain the reason? I think the reason is pretty straightforward. I mean, the reason for is too big. Yeah, it just means we cannot continue plus 1, so we definitely need to cut down. And the reason for it's divisible because we are changing, right? So the reason for the first scenario is straightforward. Scenario is quite straightforward. The reason for the second scenario is that we are incrementing the digit to the left, which we don't want to do this. We don't want to do this because we do not know if there are other values. Yeah, we just don't want to do it because we increment the digit to the left. We don't want to do this because we might miss. Right? We might miss other values in between. So we do this, and yeah, that's it. So we continue chopping off the last digit until a value becomes valid, which is until a value becomes valid. So this runs O n. I mean, technically, the worst case would be O kn, where k equal to log n. Oh, log 10n. Well, is this still considered O(n)? Actually no, because we won't hit those values. It's only just some of them. No, I just call it O(n). It might be slightly more than O(n), but it's fine. I think it's O(n). So 128 milliseconds, or we get a 48%. Okay, let's go to the discussion. Mr. Smart People, Mr. and Mrs. Smart People. Let's see what you guys have. DFS. Iterative. Python with sorting. Merge sort. Recursion. 10 lines. 1, 2, 23. Hey, I am 10 lines. I am 10 lines. Are you doing this exactly the same as I do, mister? It says the most elegant Python solution. 10 lines. I'm confident on this one. I think this one's good. So with this, new, while new is larger than n, new blah, and new blah, and so yeah, it's the same thing. Same kind of concept, except I just immediately check on this, and I check on this. Yeah, it's the same thing. Or maybe they are the same thing. Well, they say DFS. Ooh, interesting idea. So just keep adding digits from 0 to 9 to every digit and then make it a tree. Now we visit every node in pre-order. So 1, 1, 0, what do you say? And then 1, 0, 0, 1, 0, 1. Ah, I see what you're doing. I see what you're doing. So DFS current, then return. Otherwise, I always add a current. We add the current value, and we need to find all my children, and all my children are 0 to 9, and I'm going to do 10 times this. If it's larger, then we return. Otherwise, I DFS that. Good. That's a good solution. I think I might write this DFS solution. That's good. That's really good. That is good. Okay. What else do we have? Oh, that's the same idea as mine. Okay. All right. Very rarely we have time for another solution. Yeah, we are on fire today. All right, so this is the second solution. I need to credit that person. Not you. Oh, about this. The other day, I read Parkman's solution. Actually, then whatever solution he put up, I want to read. He uses. Oh, what is the thing he was using? Oh my God, he was using. I mean, like we need a dictionary, right? And we need to check if we need to check if the like a key is in the dictionary, and then he has the idea of implementing a custom object inheriting from dictionary, and he implemented the dunder missing function. So it can save him a few strokes. So he can call this. Oh, it's really. I need to find this. Is that yesterday? Holy guacamole! Maybe that's yesterday. The pairs. We try to compare. We try to compare pairs. Yeah, it could be yesterday. All right. So, anyways, I'll let this sort out, and I need your. Yeah, I need this. It's actually a good one. I like the solution. All right. So reference is this. This is a good solution. Treating the problem as a tree. So for each value, we can each value it has potentially 10 children, right? Has potentially 10 children. We DFS each tree and add the children from small to big, and that's it. Okay, so we do need a DFS, right? So DFS, what I need is the current node. We can just call it. I like current. That's the current value, and I'll have a bunch of children, right? And then what else do I need? I don't need anything else. I don't return anything. Return none, right? And I have the rest is going to be here, and then basically we just say if current is larger than n, we return, all right? Otherwise, we're gonna rest out append current, and for I in range 0 to 10, right? 0 to 9. 0 to 9, and we say